Hi guys, welcome to the another episode of Engineering Master. In this video, we will learn about current, the causes of currents, different types of current, and some circuit analysis problems. What is electric current? An electric current is a flow of charged particles such as electrons moving through an electric conductor. We know the charge of electron is negative, charge of proton is positive. What is the unit of electric current? The unit of electric current is ampere. 1 ampere means 1 coulomb of charge passing through a conductor in 1 second. 1 coulomb of charge means 6.24 into 10 to the power of 18 electrons. So that means 6.24 into 10 to the power of 18 electrons is flowing through a conductor in 1 second. Then we can say 1 ampere current is flowing through that conductor. What is the cause of electric current? In metal like copper and aluminium, the valence electrons in an atom or electrons in the outermost shell of an atom is loosely bound. It can easily be ejected. If we are not applying any voltage, there will be an electron emissions and electron flow. As shown in the video, it will be in a random direction. So there will not be a direction for it. So we don't have any use of it. It is not causing any usable electric current. If we apply a voltage or potential difference, then electron will move in a specified direction. This causes a current. This causes a usable current. For the electrons to move, we need a pushing force. Some force needs to push the electrons in one direction. This force is called potential difference or voltage. The voltage or potential difference is the reason behind the electric current. Normally, there are two types of current we are using. One is direct current or DC. This is similar to a battery current. In this scenario, the electrons will actually move from one place to another place. There will be a potential difference and the flow will be in a uniform direction from negative terminal to positive terminal. If we plot a graph against time, then it will be a straight line. The another type of current is alternating current. In this type, direction of flow of electron switches back and forth at regular intervals of cycles. That means if you plot a graph, it will be a sine wave. At the time of 0, the value was 0. The value is increasing and becoming a peak value, and it is decreasing to 0. Again increasing in reverse direction and coming back to 0. We saw in direct current, electrons actually moving from one place to another place. In alternating current, electrons are not really moving. It is moving back and forth. We can say it is oscillating in its position. You can compare this with a swing. What is the reason behind this sine wave or this type of oscillation of electrons in alternating current? The reason lies on its production. This is a diagram of a generator. We have seen this in Faraday's law chapter. We have two parts. Stator produces continuous magnetic field from north to south direction. The next part is rotor. Rotor is a coil which rotates in the magnetic field. We know when the coil rotates in the magnetic field, that EMF will induced in it as per the Faraday's laws. We have covered Faraday's laws in detail in our previous video. I will share the link in description box. So when the coil is perpendicular to the magnetic field, there will be minimal EMF or zero EMF. When the coil starts to rotate and the position of the coil is parallel to the magnetic field, what happens? The induced EMF will be maximum. Here is this position. In this position, the coil is perpendicular to the magnetic field. Here, the coil is parallel to the magnetic field. After the coil is moving from the parallel position, the induced EMF decreases and go back to 0. In this position, coil is again perpendicular to the magnetic field. Then the coil starts to rotate in another direction. So the direction of induced EMF also reverses and it became peak when the coil is parallel to the magnetic field. Again changes its direction and go back to 0 like this. This is a alternating current. So in this scenario, we can say electrons oscillates in its position. Electrons is moving forward and backward. Electrons is not actually moving from one end to other. It just oscillates or moving to and fro from its original position. This is the alternating current. Let's look at some problems. We have to find the current in 3 points. In the main line and 2 branches. First, we need to know the equation. We know as per Ohm's law, I equal to V divided by R. We have already covered Ohm's law in detail in our previous video. I will provide the link in description box. I equal to V divided by R. Then we have two resistance, 2 ohm each. This is connected in parallel. If we are connecting a resistance in parallel, what happens? The actual resistance, the overall resistance decreases. The formula is 1 by R equal to 1 by R1 plus 1 by R2. As per the formula, what will be the overall resistance in this circuit? 1 by R equal to 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is 0.5 plus 0.5. It will be 1 ohm. Overall resistance in this circuit is 1 ohm. So we know the voltage. Voltage is 20 volt. So what will be the current? I equal to V divided by R. We can see the current in main line is 20 amps. Current in branches is, what is the branch resistance? Branch resistance 2 ohm each. Then the current in branches will be 20 divided by 2. That is 10 ampere each. Total current you can see as 20 amps. Current in these branches it will be 10 amps each. So let's look at one more scenarios. In second scenario, we are connecting unequal resistance in parallel. We have 4 ohm and 2 ohm resistance connected in parallel. The equation is I equal to V by R and 1 by R equal to 1 by R1 plus 1 by R2. If the resistance is connected in series, what will be the equation? R equal to R1 plus R2. We are adding the resistance. The resistance will be increased. If you are connecting resistance in parallel, the overall resistance will decrease. The overall resistance in this circuit will be 1 by 4 plus 1 by 2. 1 by 4 is we know 0.25, 1 by 2 is 0.5. Combined resistance 1 by R equal to 1 by 4 plus 1 by 2. I equal to V divided by R. We get the value of current as 15 ampere in the main line. In the branches, equation is I equal to V divided by R. 20 divided by 4, it will be 5 ampere. In this another branch, it will be 20 divided by 2, 10 ampere. So 5 plus 10, 15 ampere in the main line. In the branches, 5 ampere and 10 amperes. The reason behind different current in different branches is the splitting of electrons. Electrons is splitting between these two branches. In the branch with low resistance, the current will be more. In the branch with high resistance, the current will be less. The overall current of these two branches will be the total current in the main line. That's it guys. I think you got a fair idea about the current and its concept. Let's see in the next video. Bye.